Hi guys, this is O-level chemistry, paper 12, June 2015, question 11. Ammonia is manufactured from nitrogen and hydrogen by the Haber process, and the equation is given. What is the percentage yield when 60 kg of ammonia is produced from 60 kg of hydrogen? So, according to this equation, 3 moles of hydrogen produces 2 moles of ammonia. So, the mass of 1 mole of hydrogen gas would be 2. So, 3 into 2 would give us 6 kg of hydrogen producing 2 into 17, which is equal to 34 kg of ammonia. So if 6 kg produces 34 kg, then 60 kgs should produce, this would be 60 upon 6 into 34, which would give us 340 kilograms of ammonia. However, in this question, it is said, what is the percentage yield when 60 kg of ammonia is produced? So out of the 340 kgs that should have been produced, only 60 kg is produced. So we need to find out the percentage yield. So we would do 60 upon 340 into 100. This would give us a value of 17.65%, which would make option B the correct option for this question. Question 12. What is the relative molecular mass MR of CuSO4.5H2O? Okay, so we just need to add up the AR of the atoms multiplied by the number of atoms present. So copper has an AR of 64. Sulfur has an AR of 32. Oxygen, there are 4 oxygen atoms. So this would be 16 into 4, which would make it 64. Next, we have got 5H2. Hydrogen has a mass of 1, so 5 to the 10. There are 10 hydrogen atoms present, so this would give us 10. And there are 5 more oxygen atoms present, so that would be 16 into 5, which would give us a value of 80. So adding up all of these together, we end up with an MR of 250, which makes option D the correct option for this question. Question 13. The list shows some substances that conduct electricity: aqueous sodium chloride, copper, and graphite. In which substances are only electrons involved in the conduction? So in aqueous sodium chloride, the conduction is done by Na positive aqueous and Cl negative aqueous ions. So instead of electrons, we've got ions conducting electricity. In copper, we've got movement of electrons. In graphite, we've got movement of electrons. So according to this question, out of the list, substance 2 and 3 are the ones that have only electrons involved in conduction, making option B the correct option for this question. Question 14. Cesium is a group 1 metal. Which reaction involving this element would not produce hydrogen? Adding cesium to ethanoic acid. Cesium is a metal, ethanoic acid is an acid. So metals react with acid to produce salt and hydrogen gas. So this will produce hydrogen gas. Next, adding cesium to water. Cesium is a group 1 metal. It will react with water, producing cesium hydroxide and releasing hydrogen gas. So hydrogen will be produced here as well. Electrolyzing aqueous cesium chloride. Since the solution is aqueous, the gas produced at the cathode would be hydrogen gas. So hydrogen is produced in this method as well. And electrolyzing molten cesium chloride. Since cesium chloride is molten, there is no involvement of water or any source of hydrogen. So the cathode would have cesium metal being deposited on it, and no hydrogen gas would be produced during this electrolysis, making option D the correct option for this question. Question 15. The energy diagram represents a chemical reaction carried out both with a catalyst and without a catalyst. Okay, this is an exothermic reaction. What is the enthalpy change for the catalyzed reaction? Okay, so the only difference between the two energy profile diagrams is the activation energy, because a catalyst lowers the requirement of activation energy. A catalyst has nothing to do with the enthalpy change of the reaction. So whether it is an uncatalyzed reaction or a catalyzed reaction, the enthalpy change would remain the same, which would be the difference from this part right up till this part. So we have 100 to 50. So the delta H value here would be minus 50 because the energy of the product is lesser than the energy of reactants. This makes option B the correct option for this question. Question 16. Hydrogen reacts with iodine to form hydrogen iodide. This is a slow reaction. H2 gas plus I2 gas gives 2Hi gas. 1 mole of hydrogen gas and 1 mole of iodine vapor were mixed and allowed to react. After T seconds, 0.6 moles of hydrogen remained. What is the number of moles of iodine remaining after T seconds? So, according to the given equation, the molar ratio of reaction of hydrogen to iodine is 1:1. So, if 0.4 moles of hydrogen reacted in T seconds, according to the molar ratio, 0.4 moles of iodine vapor also reacted. So, if the remaining quantity of hydrogen is 0.6, then the remaining quantity in moles of iodine would also be 0.6 since the molar ratio is 1:1. This makes option C the correct option for this question. Question 17. Acidified potassium manganate 7 is used as a test reagent. When it is added to an aqueous solution of compound X, the color of the test reagent changes from dash. This color change shows that X is dash. Okay. So if acidified potassium manganate 7 is used, its own color is purple. And when it is added to compound X, the color changes. So the color change would be purple to colorless. This eliminates options A and B. And since potassium manganate has been reduced, making it an oxidizing agent, right? So it is an oxidizing agent. So whatever has reacted with it has undergone oxidation. Therefore, this color change shows that X, that is the solution that reacted with potassium manganate, it got oxidized. This makes option C the correct option for this question. Question 18. You are supplied with dilute hydrochloric acid together with copper solid, magnesium solid, aqueous lead nitrate, aqueous silver nitrate. How many different insoluble chlorides could you make? Okay, so copper plus HCl, we will have no reaction because this is dilute hydrochloric acid and copper being less reactive than hydrogen will not displace it from hydrogen chloride. Next, we've got magnesium metal reacting with HCl. This would produce magnesium chloride, which is a soluble salt, and it will release hydrogen gas. Next, we have aqueous lead nitrate. Lead nitrate is PbNO3 twice. When this reacts with HCl, this would produce lead chloride, PbCl2, which is an insoluble chloride, and it would produce 2 moles of HNO3. So this is one insoluble chloride that has been produced. In the next reagent, we've got silver nitrate, AgNO3. When this reacts with HCl, this produces AgCl, which is another insoluble chloride, and it also produces HNO3. So silver chloride is the second insoluble chloride that would be produced out of these four reactions. So in total, two insoluble chlorides have been produced, making option B the correct option for this question. Question 19. In the graph, curve 1 was obtained by observing the decomposition of 100 cm cube of 1 mole per dm cube hydrogen peroxide solution catalyzed by manganese 4 oxide. Okay. Which alteration to the original experimental conditions would produce curve 2? Now, curve 2 is a bit slower in production of oxygen, but the volume of oxygen produces greater. So the only change that would bring about an increase in the volume of oxygen produced would be if more of the reactant is present. So adding some 0.1 mole per dm³ hydrogen peroxide solution, this increases the reactant. So this should be the answer. Next, lowering the temperature. Change of temperature will have no effect on the amount of oxygen gas produced. Using less manganese 4 oxide, increasing or decreasing the amount of catalyst used will have no effect on the volume of oxygen gas produced. Using a different catalyst, this would have an effect on the rate of reaction but not on the volume of the product, which is oxygen, that is there on the y-axis. So volume of oxygen would not be changed by using a different catalyst. As a result, the correct option for this question is option A. Question 20. A colorless solution reacts with magnesium to form a salt and hydrogen gas. How is this solution acting? As a base, magnesium metal will not react with a base. As a reducing agent, magnesium is oxidized to Mg2 positive ions. So it is acting as an oxidizing agent, not a reducing agent. As a solvent, magnesium metal is not dissolving, it is reacting. So solution is not acting as a solvent. As an acid, yes, because Mg on reaction with any acid, let's take the example of HCl. So 2 moles of HCl would produce a salt, MgCl2, and it would release hydrogen gas. So whatever solution magnesium is reacting with has to be an acid. So this makes option D the correct option for this question.